Hey guys, welcome back. Why should I am saying welcome back? It's my point. Hey guys, let's solve the today's daily problem. Okay. So the problem is the number of longest increasing subsequence. Okay. So we have to find the longest subsequence that are increasing in order. Okay. Like we have the problem like 1 3 5 4 7. So that there could be two answers 1 3 4 7, 1 3 4 7. Okay, or 1 3 5 7. Okay, means subsequence. We can choose any index. Okay, so I have a array like this. Now what I can think of the brute force is I can use recursion. Okay, the recursion. What can I do is take something subindex from 0 to 0, and then I can choose an index. Okay, any index which is greater than, which should be greater than or equal to the previous. Oh, previous should be less than or equals to the next. Okay, so we got the point. So what we can go is like this. We have an array, an empty array. Then we can think of either go for 1, or I can go for 3, I can go for 5, I can go for 4, or I can go for 7. Exactly, can or cannot. Now if I choose 1, we can choose either 3, 5, 4, 7. It's like that. And if I go for 3, then we can choose 5 4 7. And in the last 5 we can only go for 7, not 4, because 4 is less than. The array was like 1 3 5 4 7. This 5 is greater than, but the previous is less greater than the next, so we can't choose the 4, we can only choose 7. Okay, so we got the point. So instead of using recursion, I can go for the dp. Okay, you can get the recursion, you can code that yourself. Now to improve the thing, we can have a dp. Okay, simple dp from where I goes from 0 to n, where n is not included. And for j we can go for 0 to I not included. Okay, the bigger bracket means 0 is included, small bracket means n is not included. Okay, in the range. So in the starting, when we have only if we have 0 nothing, what is the maximum length? Of course 0, and the count will also 0. Okay, now if I have, oh shit, what the fuck is going on? Did I did something wrong here? Okay, so we can go if we have only one in our sub array. What will the maximum length? Of course 1. What will the count? We can only make one sub array. Okay, so what we have the index 1 3. Oh, what the fuck is the 3? 1 3 5 4 7. Okay, this was the, okay. So now I have 1 and 3 in my box. Okay, so is 3 greater than 1? Of course it is. So I can increase the length by 1, which will be 2. Okay, the count would be 1, because we can only make 1 and 3, so which is of 2 length. Okay, now with 5 we can go with 5 1, which would be of length 2. And if I go with 3, it would be 2 plus 1, which eventually would be 3, and the length count would be 1. Now if I have 4, I can go with 1 or 3 or 5, but not 5, because it is bigger than. So what will the maximum? 3, 2 plus 1 would be 3, and the max count would be 1. Now the tricky part, so 7. I can go with 7 with 3 or 1 or 3 or 5 or 4. Now if I have 1, the length would be 4. That indeed, so count would be 1. Now if I go with 4, the same length would be occurred. Then if I get 2 4, then count would be increased. So I got 2. Okay, simple theory. Nothing fancy in this problem. So what I can, let me reveal the code for you. So I make a vector of length, TP length or TP count, which I initially make them 1 on 1. I did that. This was initial. Okay. Initial. Okay. I have to raise this. This look ugly. Okay. Now I make them initially. Now I am taking a max length, max down. Just do not to, okay, to take the maximum length. Now what will be my range? 1 to n, okay, and 0 to I. Okay, I initialize with the max length of 1 and 1. Okay, I'm checking the all places, going all places. Okay, going 1 from then there and there. Okay, so if the previous is less than, then I can take that definitely. Okay, 7 is less than 5. Let's, oh, 5 is less than 7 indeed. Then we will check the simple quotient and update that. Now if I have the same length that occurred, I'm not increasing the count. Okay, now storing in the dp of I index and changing the max. Simple. If max is smaller than, then I'm increasing. If the max length is equal, then I'm increasing the count. Let's run it. I need, and now let's submit. Yeah, submitted. Quite efficient code and memory. We don't care about memory, is it? Or do we care about memory? Let me know. Okay. So see ya. Have a nice day.